Hello friends, today we are going to discuss some questions that came in GATE 2018 physics paper. So these questions will help you a lot in your upcoming entrance exam like NET, GATE, JEST, etc. So the first question is for the given unit cell of a two-dimensional square lattice, which options lists all the primitive cells? So primitive cells are given like 1, 2, 3, 4, 5, and you have to choose which unit cells are primitive. So for primitive unit cell, we know that the number of atoms in a primitive unit cell must be 1. So if we consider the first unit cell, then we can calculate the number of atoms as each atom, the sharing number of each atoms is 1 by 4. So there are total 4 atoms. So the total number of atoms will be 1 by 4 into 4 equals to 1. As for the second unit cell, we can calculate similarly. Here also each atoms have a sharing number of 1 by 4. So 1 by 4 into total number of 4. The number of atoms is 1. For fifth number unit cell, the total number of atoms will be here. These corner sharing atoms have a sharing number 1 by 4 and they are in 4 numbers. So 1 by 4 into 4 plus these side atoms, the atoms that are located in the side that have sharing number of 2, and they are also in number 2. So 1 by 2 into 2. So this will be 1 plus 1 equals to 2. Here we can see that in the corner of this unit cell there are no atoms, but in the center there is one atom. So only this atom contribute to the effective number of unit cell. So this here the number of unit cell number of atoms will be 1. And similarly for this unit cell, the corner atoms are not contributing in the unit cell. Only the middle atom is contributing to the unit cell. Similarly, here the number of effective number of atoms will be 1. So we can see that among the 5 unit cells, only 1, 2, 3, and 4. These 4 unit cells have one number of atoms, but this fifth number unit cell have in a number of atoms 2. So this will not act as a primitive unit cell. So the only primitive unit cells will be 1, 2, 3, and 4. So here we can see that the option number C is correct. Now we come to question number 3. Here you are given a table in which there are a left column and a right column. Left column depicts some experiment and right column depicts their results. We have to match the experiment with the results. For Stern-Gullich experiment, we all know that Stern-Gullich experiment, from Stern-Gullich experiment we can find the existence of electron spin. So P is 3. From Zeeman effect, we can quantify the space quantization of angular momentum. Q is 4. From Frank-Hertz experiment, we know the quantization of energy of electrons in atoms. R is 2. And from Davison-Germer experiment depicts the wave nature of particles. Come to the question number 17. Here the question is, which one of the following is an allowed electric dipole transition? A, 1s0 to 3s1, B 2p3 by 2 to 2d5 by 2, C is 2d5 by 2 to 2p half, and D is 3p0 to 5d0. Now we know that for electric dipole transition, some selection rules are, so the parity must change. First of all, parity must change means L1 not equal to L2, means L value must change. This L value should change from even to odd or odd to even. Okay. Example, if L equals to L1 equals to 0, then L2 equals to, this is the even parity, so L2 equals to either it will be either 1 or 3 or 5. If L1 equals to 1, then L2 maybe 0, 2, 4, etc. Okay, so if the first L is even, then the second L will be odd. The first L is odd, the second L will be even, means the parity must change from even to odd or odd to even. Second selection rule is delta nj equals to 0 comma plus minus 1. Third is delta j equals to 0 comma plus minus 1. Here in this question you don't have to try delta nj selection rule. You have to try only the delta j selection rule. Okay, now if we go to the answer, then we can see that in the first answer, first option, the L value is not changing here. For S, L equals to 0, and for this is L equals to again 0, so this will not be the answer. For the second case, here L equals to 1 and L equals to 2, so here L is changing from odd to even. And also the delta j value, here j is 3 by 2 and here j is 5 by 2, so delta j value is also changing. Delta j here is 1. Here L equals to 2 and L equals to 1, so here also delta j equals to minus 1, but sorry, delta L equals to minus 1, but delta j equals to here minus 2. So but in the selection rule we saw that delta j equals to 0 or plus minus 1, but here delta j is coming minus 2, so this will not be the case. This not be. And for D, option D, here L equals to 1, and for A3P0 L equals to 1, for 5D0 L equals to 2, and here J equals to J1 equals to 0 and J2 equals to 0. Here there is another selection rule, that is delta j, if delta j equals to 0, then j prime equals to 0 to j double prime equals to 0. It is not possible, it is forbidden. If when delta j equals to 0, then again j equals to 0 to 0 is not allowed. So here delta j equals to 0, it is okay. Here the selection delta j equals to 0, but here the j value is changing from 0 to 0, so this is not allowed. So our answer will be option B, that is option B, 2p 3 by 2 to 2t 5 by 2. Okay guys, thank you. Please subscribe my channel and give a thumbs up.